Okay, now I demonstrate what kind of examples that cannot be covered by our current representation. So please take a look at this. For example, if we have day one, and our day one has the first hypothesis, the first attribute to be sunny, and we leave it like we don't focus on other attributes in this stage. So guys, if it is sunny and this is the positive one, and for day two it is rainy and this one is positive, and in day three it is sunny again, but but this time it is negative. This time it is negative. So, oh, sorry. If it is overcast, for example, another kind, that is the negative one. Okay, so if we focus just only the first attribute here, so look at this. If we have the, of course, the first one is the null hypothesis, right? And S1 will be the values of this attribute. So it is sunny. And when you see rainy for find S algorithm, how can you do it? You have to change it, right? You have to change it into sunny and rainy. It must be don't care. So now in the first constraint, it can cover anything, right? Because you change sunny to don't care now to make it be able to cover rainy and sunny, right? But for the third one, that is the negative one, that overcast here, sorry, overcast here, it can be covered by the don't care, right? So you cannot make the hypothesis that cover just only rainy or sunny, not overcast in this representation. But in other representation, of course, we can change it like this one is others, but this one is not the one that we used, right? For example, we can use rainy or sunny. For example, if we use something like this, so sunny and rainy, of course, this can cover just only day one and day two, not day three. That is the one that we want, right? Right. Or maybe we can change it into not overcast, right? So these two representations are not included in our representation, right? So this is the constraint that we made in the first stage, right? We say that if there is an answer in using this representation, we can find it. If not, we cannot find, right? Because the one that can be used to cover just only day one and day two, of course, it can be like not overcast or sunny or rainy, but this one is not in our representation. So, so the bias one can be used to add to be added to our learning algorithm to make it be able to learn the concept that we want. Okay, like we make the constraint, so you can see that this one is an example. So we can guarantee that because we have some premise like we have an answer in this representation. So in this case, if an example is in this case, if this is the example of this case, of course we cannot find any hypothesis in our representation to cover just only day one and day two, right? Right. So we cannot find. It doesn't have. Okay. So this one is the bias and the constraint that we can think that okay, now I'll find is that start from null to some values and to don't care. That of course in this step it skip some sunny or rainy or not overcast, right? we can use it because we say that it doesn't have this kind of data set, okay, in our data set. Because we say that we can use this representation to find the answer. So if in this case, of course, in this case, there's no answer. Okay, so this is the meanings of the bias, and how can we prove that it can cover just only the positive, not the negative one, because we have the bias that like make the boundary, make the limitation that okay, we don't have that kind of data set in this learning algorithm. Okay, so I hope that you get the idea of the finest one.